How do you protect ADCs from EMI and RFI? Imagine trying to listen to a quiet conversation in a noisy room. That's what electromagnetic interference and radio frequency interference do to an analog to digital converter. They introduce unwanted signals that can mess up the accuracy of your readings. Protecting ADCs from these disturbances is essential for getting reliable data in electronics and embedded systems. One of the best ways to start is with filtering. You can use passive filters like inductor-capacitor networks or pi networks at the ADC input. These filters block high-frequency noise before it reaches the converter. Capacitors placed close to the ADC act as low-pass filters, shunting high-frequency interference to ground. Choosing capacitors with low equivalent series, resistance, and using them below their self-resonant frequency makes them more effective. Inductors or ferrite beads also help by acting as RF chokes, but they need to be used below their self-resonant frequency to avoid resonance issues. Common mode chokes are useful for reducing interference that appears equally on both signal lines. Filtering power supply lines is equally important to prevent noise from entering through the ADC's power pins. Next, proper printed circuit board layout and grounding play a big role. Keep analog and digital grounds separate to prevent digital switching noise from affecting the analog signals. Use a solid ground plane to create a low impedance return path and reduce loop areas that can act as antennas for electromagnetic waves. Keep your analog signal traces short and route them away from noisy digital or power traces. Avoid sharp right-angle bends in traces because they can cause signal reflections. Place decoupling capacitors very close to the ADC's power pins to stabilize voltage and reduce high-frequency noise. Shield sensitive analog traces by placing grounded guard traces or ground planes next to them on the PCB. Shielding is another key method. Enclose the ADC and sensitive analog parts in a metallic or conductive shield to block external electromagnetic fields. Use conductive gaskets or coatings to seal any openings in the enclosure, stopping electromagnetic waves from sneaking in through seams or slots. Shielding cables carrying analog signals with grounded metal braids or foil prevents radiated interference from being picked up. Power supply stability is also vital. Provide a steady, low-noise reference voltage and power supply to the ADC. Fluctuations here can directly cause errors in your digital output. Use voltage regulators with good line and load regulation to keep the supply steady even when current demands change. Filtering power lines helps reduce conducted noise that can affect the ADC. Signal conditioning can improve the situation further. Amplify and filter the analog input signal before it reaches the ADC. This process boosts the signal-to-noise ratio and helps reject out-of-band noise. Using differential inputs can also help by rejecting common mode interference, which is interference that appears equally on both input lines. Finally, component selection and placement matter. Choose components with low noise and appropriate frequency response. Place sensitive analog parts away from high-frequency digital circuits and switching power supplies to minimize interference. By combining these techniques, filtering, shielding, careful PCB layout, power management, and proper component choices, you can greatly reduce the impact of electromagnetic and radio frequency interference on your analog to digital converters. This ensures your system captures clean, accurate signals, making your digital readings reliable and precise.